For 75 years, Mercury Marine has led the marine industry with cutting-edge technology and best-in-class propulsion designs that enhance the boating experience. Mercury outboards range from 2.5 to 350 horsepower and are recognized as the most reliable and efficient in the industry, while Merc Cruiser sets the standard in performance and durability for stern drive units. Mercury is also the world's largest manufacturer of marine propellers, known globally for their performance, strength, and efficiency. And Mercury parts and accessories allow boaters to make the most of their time on the water. When it comes to propulsion, no one outperforms Mercury Marine. Hi, I'm Byron Velvick, member of the National Mercury Pro Team, and I'll be taking you inside Mercury Manufacturing to get a close-up look at the company, its products, and its people. Mercury was founded by Carl Kiekhaefer in Cedarburg, Wisconsin in 1939 before moving to the company's present-day location in Fond du Lac in 1946. A simple dairy farm in Fond du Lac was purchased by Kiekhaefer Marine and transformed into a contemporary manufacturing facility that has evolved into the 140-acre world headquarters of Mercury Marine. The manufacturing area today consists of approximately 2 million square feet of production space and stretches nearly a mile. The core of every Mercury engine starts here at Mercury's state-of-the-art foundry. This is where Mercury produces its exclusive, low-copper, highly corrosion-resistant aluminum alloy. This unique aluminum alloy is used to cast thousands of different parts that become essential elements of your reliable and durable Mercury engine. Up to 80% of a Mercury outboard's content is produced and machined right here. Mercury utilizes three main casting techniques: traditional die casting, low-pressure permanent mold, and pressurized lost foam casting. Each of these techniques requires Mercury to pour specially formulated molten aluminum alloy into the mold or casting. The method used is dependent on the part being cast. Mercury Marine is just one of a few companies in the world that has mastered the lost foam under pressure casting. Pressured lost foam casting allows Mercury to produce sophisticated components that require fewer parts. The result is a lighter weight product with improved reliability. Styrofoam molds are glued to a frame so multiple pieces of the same part can be cast simultaneously. The form, like every part, is stamped with a serial number that can be tracked from here all the way to the transom of your boat. The patterns are dipped in an exclusive coating that creates a barrier between the foam and the synthetic sand used during the casting process. Once dry, the forms are fitted with a fill funnel and placed in a cast iron vat, which is then filled with more than a ton of fine synthetic sand called mullite. The first pour fills the various nooks and crannies of the part, which will keep the molten metal out, creating passages for cylinders and other sections of the future engine. The hot liquid metal instantly evaporates the foam mold, hence the name lost foam, while the aluminum conforms to the shape of the pattern. After 10 minutes, under 70 to 140 pounds of pressure per square inch, a cylinder head is born. The part is dipped into cool water, creating a steam explosion and removing burrs and debris from the casting. The sand that was used in the casting process is collected, cleaned, and recycled for future use. After basic machining, the first of nearly a dozen machining processes, the cylinder head is given its first of many quality tests. Technicians perform a leak flow test on all water and oil passages, assuring they hold both pressure and fluid. If the part fails here, it's scrapped and recycled. If it passes, it moves on to the Mercury heat treat facility where the metal's strength and integrity are fortified. Machining is a vital step of the engine building process. Mercury Marine machinists, using state-of-the-art computer-controlled tools, finish iron and stainless steel components to exact specifications. While we wait for the cylinder head to return from the heat treat facility, let's check out the gear machining area. Quality gears are essential in providing the torque necessary to propel a boat. This gear will undergo a three-step machining process. Approximately 50 gears per hour will pass through this station. The process begins with trimming the gear surface, necessary for additional steps in the manufacturing process. Next, clutch teeth that are forged into the gear undergo a milling process. Drive shafts, prop shafts, shift shafts, and every part Mercury manufactures goes through similar machining operations. The number of steps for each part varies depending on the part's complexity. Lastly, the gear teeth are cut, and the finished piece is deburred and cleaned up. Most high-speed machining tools can perform more than one function at a time, and all of the cutting fluids, about 30 gallons a minute, are recirculated. Metal shavings left behind from the cutting and cleaning process are recycled within the facility.
These Verado cylinder heads have just returned from the heat treat facility and are now ready for Mercury's extensive corrosion protection process.
As you can imagine, marine engines spend their lives in environments that can create corrosion. Mercury engines are the most corrosion resistant in the industry. Let's take a look at why that's true. First, our cylinder undergoes a special iridite treatment process that provides a highly resistant corrosion barrier. Next, it's run through an epoxy painting process called electrodeposition paint, or EDP, which uses electrically charged paint and oppositely charged components to seal out the environment. Finally, Mercury's thicker, tougher powder paint is applied to key components. This paint is electrostatically charged and extra flexible for better long-term adhesion and protection from the sun's UV rays. On larger horsepower engines, Mercury coats the internal passageways with its exclusive salt shield, a chemical that provides unsurpassed resistance to saltwater exposure and heat. Now the parts are ready to be precision machined. The Mercury manufacturing floor is filled with different types of machining equipment. Several automated pieces of equipment are computer controlled. Cylinder heads are machined at this station. Multiple functions are completed by a single machine during each of the 10 steps of this process. Valve seats are counterbored and surfaces are shaved and smoothed to ensure a perfect fit and seal. Once again, leak tests are performed. After being tested and only after receiving the go-ahead, the cylinder head moves on for final assembly. While automation is an important component of building quality products, members of the Mercury manufacturing team also play a major role. Mercury employees on the manufacturing floor program the machines, perform quality checks, and still complete many jobs by hand.
We are in the quality audit lab where Mercury engineers ensure that machine castings are built to Mercury's exact specifications.
Technicians use a coordinating measuring machine to take hundreds of measurements for each part. In fact, about 2,000 parts per week are selected from the production line for testing here. These sophisticated devices are capable of incredibly precise measurements to within 40 millionths of an inch, equal to a diameter 100 times finer than a human hair. Testing confirms part integrity and ensures that a specific manufacturing procedure is producing the desired result. In addition to random part verification, machines are used to measure individual components during new product development, and they measure parts supplied by outside manufacturers.
The components are sent to the main assembly lines for final assembly. Let's head down to the Verado assembly line to see exactly how all these parts are put together.
First, intake and exhaust valves are installed on the cylinder head. Later, the pistons and connecting rod assemblies are installed into the engine block. Here at the bearing assembly station and all along the assembly line, computers aid employees to ensure Mercury's high-quality standards are always met. At this station, employees scan barcodes on the block and crankshaft, and the computer determines what size of bearings should be installed. Bins containing various engine parts light up to signal which parts should be used, and technicians verify that the color-coded parts match. This process ensures that only the right part goes into the right place each and every time.
Computer-aided critical measurements are used throughout the entire assembly process to ensure years of trouble-free operation on the water.
The block continues down the assembly line where additional components are installed and tested. Mercury Marine uses its exclusive long bolt process to marry the Verado cylinder head, block, and bed plate. This process provides long-term durability and a maintenance-free valve train. That means the valve train never needs adjustment, which saves you money. Once the block is assembled, a cold spin static test is conducted to check compression and sound levels. The crank is turned at 600 to 1000 RPMs to verify that every part is properly placed. The next step is marrying it to the main frame of the outboard engine. Here on the assembly line, the various pieces of the Verado come together to create the final product. A robotic J-hook assists employees by moving the engine from station to station during the final stages of the build. The heavy-duty advanced midsection, clamp brackets, and standard power steering cylinder are then assembled. Engine oil is sumped or recirculated through the midsection separately from the exhaust. This process, which is exclusive to Mercury, ensures the oil is not preheated. Further along the assembly line, the engine power head is attached to the advanced midsection. Next, a slew of Verado exclusives are put in place, including digital throttle and shift, a supercharger, and the engine oil cooler. Here, the charged air cooler is installed, and the next 4 stations complete the electrical components. And at last, the gear case assembly is attached. The engine is topped off with oil and is ready to run. But before it ships, Mercury tests the engine one last time in a water-filled tank to confirm that all components perform flawlessly. Every Verado engine is run at various RPMs during an 8.5-minute test cycle that measures power output, all fluid pressures, component temperatures, engine and electronic sensors, and noise and vibration. Every outboard Mercury manufactures is similarly tested. Mercury considers this a final opportunity to be certain your outboard will be the most durable and reliable you will ever own. The final steps include installation of the outer midsection chaps, grommets, and upper cowling, and giving it a thorough cleaning before it's wrapped and crated. The outboard is now ready to be shipped to your local Mercury dealer or one of the many boat builders that choose Mercury to power their boats.
That's Mercury's outboard story. But there's more to see here at the company's world headquarters in Fond du Lac, Wisconsin. Here, Mercury also manufactures its stern drive engines as well as its Alpha and Bravo drives in the same facility.
The same attention to detail and quality control are built into every MerCruiser product that comes down the line. Let's take a quick look at the way MerCruiser's flagship 8.2-liter stern drive package is assembled. Once the long block is assembled, the engine heads for the first of 2 assembly lines where it is further marinized and prepped for painting. Robots make it easy to move the engine from station to station. Now, with its baked-on paint finish, technicians install the electrical distribution panel, alternator, cool fuel module, and other key components. The engines are filled with oil and head for the test cells where they are attached to sophisticated testing equipment. During the series of tests, they also go through an accelerated break-in. Just like Mercury outboards, every MerCruiser engine is tested to ensure it runs flawlessly before it leaves the plant. The transom midsection will become part of the boat hull when it is installed. It connects the engine to the outer drive and propeller. Here, the exhaust bellows, trim limit sensors, and power trim cylinders are installed. Electrical checks are also conducted during the bracket assembly. A stern drive unit consists of an engine and a drive. We visited an engine assembly line. Now let's head over to the Alpha line to see how a drive is built. Much like we saw on the Verado line, computers aid in selecting the correct gear backlash to provide long-term durability. Once assembled, each drive is subjected to rigorous testing. The final graphics are then applied and the drive is boxed and ready to ship.
At Mercury Marine, our manufacturing is all about providing great marine propulsion, which in turn gives you a fantastic boating experience. Thank you for joining me on this trip through Mercury Marine. We'll see you on the water.